All right, good afternoon. This is our NASA Mars Lander Final Report project for the First Year Engineering Lab, Section 0001, Summer 2026. Our company name is Pakaki Martin, and our team members are Noah Benjamin and me, Hugo Mencius. So a quick little overview of our report. We'll start off with introductions, get to know each team member. We'll go into the background of the project, requirements and things like that, our final decided design, and how we went through manufacturing, and our final test results, and our conclusion. So to start us off, we have Noah Benjamin. He is our construction manager, and me, Hugo Mencius. I am the project manager and verification and test manager. So a little bit about the background. We have been selected as a potential contractor for a Mars lander for NASA. We'll compete with other contractors, and we'll demonstrate our completed vehicle on launch day. We'll be provided a list of materials, and we'll be tasked with protecting 2 pilots. In our case, we'll use eggs, and we will perform the test twice, and we'll provide the presentation. So for phase 1, some of the customer requirements that have been asked of us are: we will deliver the astronauts to the surface of Mars. Performance will be demonstrated during video recorded tests on launch day. Our design will carry 2 pilots, the eggs, and it'll be a reusable design, and it should be accessible for ease of access in terms of if you're seeing like loading, unloading. The vehicle shall survive a 12-foot drop minimum, and it'll protect the pilots. It'll be constructed with a budget of no more than $15 on purchase materials, and the lander demonstration will withstand the impact of a tile floor. The camera back up. Okay. So phase 1 of the summary contract requirements, very similar, 12-foot drop. The pilots will weigh approximately 60 grams. There's no size limit for our vehicle, no weight limit. We have a $15 budget, and we'll land on tile flooring, and we will control the vehicle orientation in terms of our final design, which we will get into as we show the design. So I'll hand it off to Noah, our construction manager, who will go into the final selected design.
Yeah, so now I'll explain our final design and manufacturing process. So our selected design uses a hexagonal cardboard shell surrounding a smaller box that held the 2 pilots. And the drawing shows the front side, the angled views, and or the front, the side, and the angled views with our initial measurements. The outer shell was designed to absorb the initial landing force, while the rubber band suspension allowed the inner box to move during impact. Cotton and paper cushioning provided additional protection around the eggs. This drawing guided our construction, although some details were changed while building. So this table shows the materials included in our original budget. Our largest expense was 2 large cardboard sheets, which cost $10 total. We also purchased copy paper and bubble wrap, 3 packs of rubber bands, and cotton balls. Our tape, scissors, and cutting tools were already available at no cost. We did not purchase grocery bags or special salvage materials. Our total purchase cost was exactly $15, so we stayed within the project budget. So with these, we did not use every material we originally purchased. Only 1 cardboard sheet was necessary because the finished vehicle was smaller than expected. We purchased bubble wrap, but did not have enough time to install it. We also opened only 1 pack of rubber bands and used 6 individual rubber bands. The remaining 2 packs were untouched. Although fewer materials were used, the vehicle still completed its purpose perfectly fine. Yeah, so this is just a picture from class that shows the materials available before construction, all laid out properly with the cardboard, the copy paper, bubble wrap, cotton balls, rubber bands, and our tools. And we mainly worked with the inexpensive materials that could be measured, cut, and folded, and adjusted as construction progressed. Yeah, so this is our original construction plan, steps 1 through 4. Our original plan was we would begin with cutting a continuous piece of cardboard that measured about 10 or 24, 10 by 24 inches. We divided the longer side into six equal 4-inch sections. Instead of cutting these sections apart, we plan to score the dividing lines and fold the sheet into a hexagonal shell. The two ends would then be joined together by use of rubber bands as well as tape. Next, we plan to trace the openings and cut two matching hexagonal end pieces. Finally, we plan to build a 6 by 3 by 3 inch inner box with a hinged opening and a bubble wrap lining. Now, through steps 5 through 8, the next part of the plan was involved with creating reinforced cardboard attachment points on the inner box, the six outer panels, and the two end pieces. One end piece would be attached first, the inner box would be placed in the center. Six rubber bands would connect the box to the surrounding panels. Four additional rubber bands would connect the box to the two end pieces, giving us 10 suspension bands altogether. We would then adjust the tension until the inner box remained centered with approximately 2 inches of space around it. The bands needed to support the box while remaining flexible enough to stretch during impact. Now, with steps 9 through 13, before loading the eggs, we plan to test the suspension using objects weighing approximately the same as both pilots, which we were given in class, the little plastic eggs, and using low height drops, which show whether the inner box contacted the shell or whether any attachment points needed more reinforcement. Each egg would then be wrapped in bubble wrap and surrounded with cotton balls. After loading the pilots, the box would be closed and the second end piece attached to it as well. And then we also plan to fold the copy paper into compact bumpers for the outer panels and ends. And then we would have a final inspection, which would confirm that the pilots could not move and were secure and that the rubber bands were in place and everything was, going as planned. So did make some changes to the construction plan when we actually did end up building it. And several parts of the plane were changed during the actual construction. So two rubber bands were used to join the ends of a large outer shell. We added a rectangular opening to the inner box so the pilots could be loaded and removed easily. The bottom and the two walls were made from one folded piece, while separate square panels attached were completed with the remaining sides. We used six rubber bands in the final vehicle. Two joined the outer shell, three secured the inner box, and one connected the inner box to the outer shell. We did not install the separate end pieces or external paper bumpers. Bubble wrap was also omitted. Instead, cotton balls cushioned the bottom, a cardboard divider in between the pilots, and then we also had a crumpled paper attached to like the lid to protect them from hitting the top of the door. So some challenges during construction was that our main challenge was limited through mainly our time and lack of another teammate. Creating reinforcing attachment holes for the original 10-band suspension system took longer than expected. So we simplified it to one band, connecting to the inner box to the outer shell. Joining the outer shell was also difficult, so two rubber bands were added to hold its ends together. The original inner box made loading and unloading the pilots difficult, which led us to create the rectangular top opening. These solutions allowed us to finish the vehicle while preserving its main protection features. Yeah, and then these are just our final vehicle photographs, which show the completed top, front, and side views of it. The outer cardboard maintained its hexagonal form, and the side view shows the smaller pilot component positioned inside the shell. On yeah.
So overall, um, for test one, our design was a success. Our dimensions ended up being 33 centimeters long with a 23 centimeter width and a height of 25 centimeters. Um, our loading time was exceptionally quick with 9 seconds, and our drop was also successful. Our pilots survived, no injuries, and our design remained intact. No, there was no visible damage as shown here on the side. Um, Overall, test one was considered a success, and we moved on to the next test. So here are the test 1 and 2 videos, respectively. Let me play the video for test 1. So as you can see, our test 1 was a success. Our design remained perfectly intact. There was no visible damage as far as we could see. The pilots were safe and sound, and there was no damage. So overall, test 1 is a good success. And now on to test 2. So just like in test 1, our design was a success. Our pilots were completely safe and sound. And in both videos, you can see that our load and reload and unload times were very quick compared to the other groups. We attribute that to our case design, where we intentionally designed an easy access door mechanism, as the construction manager presented earlier. So here are photos of the vehicle integrity and our pilot conditions. No damages are seen here, and no damage seen here. So in both cases, again, as shown in the video and as mentioned before, there was no visible damage and our design integrity held. So focusing more on test 2, here is our DD250. Our load time was a little longer, but overall still exceptionally quick, and our unload time took a little longer as well. And here are the vehicle integrity photos. Again, no visible damage, pretty successful. So in conclusion, what do we accomplish? Our design was a success. Our pilots were okay. No visible damage. The outer structure was formed together in a hexagonal shape to create almost like a cushioning shell. Um, the inner box was also more so of a fail safe, just in case that our shell had too much leeway, too much give, which is why we padded the inside and we created almost like a hinging door, also lined with cushioning. And also we put a cardboard divider in between both pilots to keep them from striking each other whenever they land. So again, as mentioned before, both pilots more than survived test 1. They were unharmed, as well as in test 2. Our vehicle design held, and it can be reused quite easily. It's efficient in both loading and unloading, and it held, it endured. So approximate impact time was 0.86 seconds across both instances. Load times differed a little bit. Final dimensions maintain form overall. In our AI analysis, we use ChatGPT to estimate the impact time by analyzing each frame. Um, we couldn't really time that, so it was forced to use frame references to estimate, and then the data extraction recorded the values from about 12 feet and converted it to meters. And some of the uncertainties we faced was that the impact time, since it was estimated, it was pretty theoretical. It was only using photograph. It could be subject to frames, how many frames, the refresh rate of the camera, and that there was only 2 tests completed. For rework and redesign, there's no damage. The pilots were intact. Dimensions remained consistent, and no redesign was necessary, although the access opening could have been improved for faster unloading. No changes were made between test 1 and 2, since it was successful during both tests, and the second test was equally as successful as the first. Nothing, we would change not much about our design. And yeah, thank you for watching our presentation.